Okay, here the person makes an open top box out of a square piece of cardboard material with length 20 inches on one side. She does this by cutting equal sized squares of length x out of each corner as shown in this diagram. So we have to determine the length, width, and height of the box so that we can determine the size of the square that she can cut and the volume of the box is maximum. So if she cuts x inches on either side of the one of the length of the square, then the length of the cardboard will become 20 minus 2x because the length of the cardboard is 20 inches. Cutting 2x gives 20 minus 2x, which forms the length of the box. And similarly, if she cuts x from both corners of the other side, then 20 minus 2x will become the width of the box. And folding this cardboard material to convert this into a box, this x becomes the height of the box. So therefore, we can write down the volume of the box. This equals length times width times height. And so this equals the length of the box is 20 minus 2x times the width of the box is 20 minus 2x, and then the height of the box is x. So let's simplify this and determine the x such that the volume is maximum. We can rewrite this v as v of x because it's a function in x. And when we combine these two terms, we can write down this as a binomial square, that is 20 minus 2x quantity square times x. Now we want to find the x such that the volume is maximum. So considering this volume as the v of x function, we first to find the critical point of this function by setting up the first derivative equals 0. So let's do that. I'm going to find the derivative of this v of x. So before I do that, I can write down this in uh, by multiplying these terms or simplifying this. So I'm going to expand this binomial square. 20 minus 2x binomial square is 20 square, which is 400. Then 2x quantity square, which is 4x squared. Then product of these two multiplied with 2, that is 20 times 2x times 2. 20 times 2 is 40. 40 times 2 is 80. We also have a negative, so it is a negative 80x. Basically, I'm using this binomial squares formula. A minus b quantity square equals a squared plus b squared minus 2ab to expand this binomial square. And this has to be multiplied with x. Let's simplify this. V of x, this equals, we can distribute this x into the terms inside the brackets. So we get 400x plus 4x cube minus 80x squared. Let's write down this in decreasing powers of x. So here we have v of x. Write the 4x cube term first, then the square term, that is negative 80x squared plus 400x. We need to find the derivative and set this up equal to 0 so that we can find the critical numbers. So let's do that. We will now differentiate this. So this equals v prime of x, and this equals the derivative of 4x cube is 4 times 3 is 12, and then x squared. We use the power rule to find the derivative of x cube, minus the derivative of 80x squared is 80 times the derivative of 2x, which is 160x, and then the derivative of 400x is 400 times the derivative of x is 1. So I just write 400. Now we have to set this equal to 0, that is v prime of x equals 0, and solve for x. So replacing this by 0, we get 0 equals 12x squared minus 160x plus 400. We can divide both sides by the common factor 4. So we get 0 equals, this is 3x squared minus 40x plus 400 divided by 4 is 100. Now this is basically a quadratic equation. We have to solve for x. You can solve it by factoring or by formula method. So let's put this in into factor form so that we can solve for x. We see that the product is 3 times 100 is 300, and then the sum is negative 40. So we can split the middle term as 10 times 3. These are the two numbers which gives product as 30. Also, I can put this as negative 10, negative 30, so that the product is positive 300 and the sum is negative 40. So basically, I'm going to split this negative 40x as I put this 0. In fact, I can rewrite this as I put the 3x squared term, and we split this negative 40x as negative 10x, negative 30x plus 100, and this equals 0. Now we factor x from these two terms as well as 10 from these two terms. So let's do that. Factor x, we get 3x minus 10. I then factor negative 10 from these two terms. So I will put 3x minus 10. This equals 0. Let's verify this. Negative 10 times 3x is negative 30x. Negative 10, negative 10, product is a positive 100. And x times 3x is 3x squared. X times negative 10 is negative 10x. So this is perfect. Now we see that we can factor this 3x minus 10 from both the terms. So which gives 3x minus 10 I'm factoring, and then we'll be left with x in the first term and then minus 10 in the second term. So this equals 0. So we have written this quadratic expression or the equation into product terms. 3x minus 10 times x minus 10 equal to 0. Now using the 0 property, we say that 3x minus 10 equals 0, or x minus 10 equals 0, and this gives x equal 10 by 3, and here this gives x equals 10. Let's check both values if both are possible or only one of them is possible. If we plug in x equal to 10 into the volume equation, or realistically if you look into the problem situation, if we cut 10 inches from here and 10 inches from here, leaving us 10 10 is 20. So if we remove 20 inches from 20, it will be 0. So there is no cardboard material available to form the box. So we don't form a length for the cardboard so that we can create a box. So x equal to 10 is not possible. So we ignore this one, and we take this 10 by 3. This one is approximately 3.3. We can also verify that at this value of x, the volume is maximum. For that, let's copy the first derivative. That is, we have v prime of x equals 12x squared minus, in fact, we can take this simplified, or we can just take this 12x squared minus 160x plus 400. Now we have to find the second derivative. This equals 24x minus 160. Let's plug in x equal to 10 by 3 into the second derivative. And so we get 24 times of 10 by 3 minus 160. And this gives this we can cancel as 8 times. 8 times 10 is 80 minus 160. So this one is negative 80, and this is less than 0. So when we plug in this critical point of the volume function into the second derivative, we get the second derivative is less than 0. So according to the calculus, when the second derivative is negative, by plugging the critical point, we then see that volume function is maximum, or the critical point is a point of maximum. That is x equals 10 by 3 is a point of maximum. So thus we have verified that volume is maximum when x equals 10 by 3. Therefore, we say that the person should cut x equals 10 by 3 inches so that the volume of the box is maximum.